We want to determine algebraically whether the functions are inverses of each other, and then we're going to look at it graphically to see how they're inverses of each other. So algebraically, well, that's where you take one equation, switch x and y, solve for y to get the equation of the inverse, and if it matches the other equation's inverse, then you know that they're inverses. If they don't match, then they're not inverses. So in my first equation here is y equals 3x minus 6. If I switch x and y, I would get x equals 3y minus 6. Move the 6 over to the other side, divide by 3, and I get y equals x plus 6 all divided by 3. Now I've got y by itself. Does it match the other equation? The other equation is x minus 6 divided by 3. We got x plus 6 divided by 3. They're not the same. So no. They are not inverses because the equations don't match. Sometimes you have to do a little bit of manipulation to get the equations in the same form before you can say they match or don't match. But in this case, they're in the same form. One's x plus 6, one's x minus 6. They're not the same. To look at that graphically. So what we're going to do is I'm going to graph equation 1 in blue. I'm going to graph equation 2 in green. So equation 1 was y equals 3x minus 6. It's a line. It's in y equals mx plus b form. So you know that your y-intercept is at minus 6. Your slope is 3. So you go up 3 over 1, up 3 over 1. There's your blue equation. Now your green equation was y equals x minus 6 divided by 3. And we have to graph this. First of all, when you're graphing an equation, you have to be able to look at it and decide what kind of graph is this. Okay? Is it a parabola? Is it a line? Is it an x cubed graph? So first of all, you would need to be able to recognize that that's a line. It's just got a single x. It's a line. However, also notice that it's not in the form that you like to graph from. It's not y equals mx plus b. So we might have to do a little bit of work to manipulate this. Are you guys okay that this is the same as the x divided by 3 and the 6 divided by 3? And with that, I could write x divided by 3 as 1/3 x, and 6 divided by 3 is just minus 2. So what I've done is I've taken my algebra skills, I've rearranged things, so now, hey, now it's in y equals mx plus b form. I know that my y-intercept is minus 2. I know my slope is 1/3, so I can go up 1 over 3, up 1 over 3, and draw that graph. So how can we tell from our graphs that these are not inverses? Just because they're not? They're not this. Well, inverses don't have to be the same graph. Two x values on the same y. Okay, so if we're talking about, like, an inverse is a flip over this line, right? So if they were inverses, this point on the green one should also be on the blue one. And this point on the blue one should also be on the green one, and they're not. So that would be definitely one way to say these are not inverses. You could also look at points, right? Like this point has 0, -6. But if you switched them, -6, 0 is over there. That's not on the green one. That would have to happen if they were inverses, right? The blue one, if you reflect it over that line, would be here. So there's a number of ways that we can look at the graphs and say they're not inverses. The points don't switch. On the line y equals x, the ones that are supposed to be the same aren't there. You could even just say it isn't a reflection over the line y equals x. It doesn't match up. Okay, that was our first equation. Draw a line here to split this up. We'll now look at equation 2. Equation 2 is a parabola and a square root graph. And the parabola has afterwards x bigger than or equal to 0. That's a restriction on the x values, which means it's a restriction on the domain. X is bigger than or equal to 0 means we're only taking half of that parabola, not all of that parabola. So how do we find an inverse? Well, again, I'll call this equation 1 in blue. I'm going to switch x and y. So I have, write that down, switch x and y. X equals negative y squared plus 3. And the restricted domain will also switch. And you'll only consider this equation when the y values are bigger than or equal to 0. So now if I'm solving for y, I'm going to move the 3 over to the other side, get the y squared by itself, square root both sides, where you would get plus or minus. But since y has to be bigger than or equal to 0, the only one that makes sense is the positive one, negative x plus 3. Does that match with what they have? They have 3 minus x. We have negative x plus 3. Are they the same or different? Yes. They're the same, right? It's just the order in which you write it. They are the same. So algebraically, we can say, yes, they are inverses. Now graphically, let's look at the graphs. Again, I'm going to color code them. I don't know if I labeled. I'll label the second one in green again. We're going to start by graphing negative x squared plus 3 with the domain restriction as x is bigger than or equal to 0. First of all, transformations. Can you see that's a parabola? Vertical reflection going down, then shifted 3 up. Shifted 3 up, we're going to have 0, 3. That parabola we're only doing when x is bigger than 0, so we're only doing this side, over 1, down 1, over 1, down 3. That's our parabola that we have. It has the point 0, 3. It has the point 1, 2. It has the point 2, negative 1. My green graph. My green graph was 3 minus x. This is written a little bit funny. We never do our translations left and right before the x. So probably you would like to write this as negative x plus 3. Can you see that that has a horizontal reflection and a horizontal translation? Which way will it translate? Okay, you see the plus 3? You want to say to the left? But this is the one that has that special note. Whenever you have 2 horizontal things, you always have to write it in factored form. So I would have to rewrite this with the negative factored out. It's actually going to be 3 to the right. So now, I'm thinking of a square root graph. Horizontal reflection, it's going this way, and then moved 3 to the right. 1, 2, 3, so here, then here, then here. It would have 3, 0, 2, 1, -1, 2. Graphically, can you see that they are reflections over the line y equals x? Can you see that all the coordinates have been switched? But graphically, can you see yourself making a mistake with which way you shift it because of that special rule, where if you have that horizontal translation and a horizontal reflection, you have to write it in factored form. Okay? Something that you can do as a check. If you're unsure, did I do it right, you can plug in a point. Like, what happens if I plug in 2? 3 minus 2 is 1. Square root of 1 is 1. So I know that 2, 1 is a correct point. Yes?
Weren't the two equations the exact same equation? Like once you switch the x and the y around, then you...
Like this one to this one? Is that what you mean?
Yeah, like in part 2,
Oh.
two different equations, weren't they both the exact same?
When you switch x and y, you're finding the inverse. But finding the inverse's equation isn't going to be equal to the first equation. It's going to be equal to the equation after it's flipped over the line.
Yeah.
So this square root equation isn't the same as the parabola.
Well, wasn't the inverse of that parabola like the exact same as the
Yes.
y is equal to 3 minus
Yes. So once we did the inverse algebraically, we got negative x plus 3, which is exactly the same as 3 minus x.
Then why are they different on the graph?
Well, one thing we're doing is we're graphing the x squared part, which is part of a parabola, and the other one is graphing the square root graph. And an inverse and its original graph aren't going to be the same. An inverse and its original graph, this blue one was the original one, and the green one is the inverse.
It's just one half of the...
It's just 1/2 of the parabola. So like here's the part you didn't draw of your parabola.
And then the green one was the inverse of the first equation of the parabola?
Yeah, the green one was the second equation, which in this case happened to be the inverse, right? And the first one we did, the green one was the second equation, which wasn't the inverse, which we could see once we drew the graph. So I've labeled 1 and 2. 1 is the blue one, 2 is the green one, and that's what we've graphed here. 1 is the blue one, 2 is the green one. In this case, they happen to be inverses, and we can see it both algebraically and graphically. So your practice questions here are 7, 8, 11, and 13, and in my notes, I put a little star beside 11 and 13, meaning that those are problem-solving questions where they're kind of on your exam. You're going to get a couple questions that are worded different, that are going to make you think. Those are the ones that are a little bit different that'll make you think. You have the tools to figure it out, but it won't be like, oh, we did one just like this, so I can do it quickly. You will have to problem solve a little bit.